Imagine walking outside on a clear night. You look up, and there it is, the universe, an infinite ocean of stars, billions upon billions of them scattered across the black canvas of space. And yet it's dark. Not just dim, not a little gray, but deeply, profoundly black. If the universe is filled with stars, why isn't the night sky as bright as the surface of the sun? Why is the universe dark at all? This question is one of the oldest and simplest in science. It's called Olbers Paradox, named after the German astronomer Heinrich Olbers, who asked it about 2 centuries ago. But the mystery goes back much further. Philosophers and scientists throughout history, from Kepler to Newton to Feynman, have puzzled over it. The logic seems simple. If there are countless stars in every direction, and if the universe is infinite and eternal, then no matter where you look, your line of sight should eventually hit a star. The whole sky should glow as bright as the sun. But it doesn't. It's dark. That darkness, Feynman once explained, is not just an absence of light. It's a clue. A deep cosmic clue about the nature of the universe itself. Let's start small with something familiar. Imagine standing in a forest surrounded by trees. If the forest stretches infinitely in all directions, and the trees are evenly spaced, then no matter where you look, your line of sight should hit a tree trunk. You shouldn't see gaps between them. But in the night sky, we see gaps everywhere, vast regions of darkness between points of light. So something about our cosmic forest must be different. Feynman might say, well, perhaps the trees, the stars, aren't infinite. Maybe there's a boundary to how far we can see. And that's exactly the first clue. Light travels at a finite speed 300,000 kilometers per second. Fast, yes, but not infinite. That means light from distant stars takes time to reach us. And if the universe has a finite age, say around 8 billion years, then we can only see stars whose light has had enough time to travel to Earth. The rest of the universe, beyond that horizon, is invisible to us, not because there's nothing there, but because its light hasn't arrived yet. That's one piece of the puzzle. But even with this limitation, shouldn't the part we can see be bright enough to fill the sky? Not quite. Because another truth intervenes. Stars don't last forever. They're born, they live, and they die. The universe isn't static, it's dynamic, evolving. The stars we see are part of a cosmic cycle, not an eternal blaze. There was a time before stars existed, a time when the universe was dark, what cosmologists call the Dark Ages. Light itself took time to emerge. And here's where Feynman's way of thinking becomes powerful. He'd say, don't just ask why it's dark. Ask what that darkness is telling you. When we look into the dark sky, we're not seeing an empty void. We're seeing the edge of time itself. The darkness is the light that hasn't yet arrived, the echo of a universe still unfolding. There's another twist, the expansion of the universe. When light travels through expanding space, it stretches. Its wavelength grows longer, moving from visible light into infrared, microwave, or even radio waves, forms of energy our eyes can't see. The star's light doesn't disappear, it simply fades beyond our perception. The darkness isn't the absence of light, but a transformation of it. The afterglow of the Big Bang, the cosmic microwave background, still bathes the universe. It's everywhere, even between the stars, but it's cold, faint, and invisible to our eyes. The night sky is filled with light we cannot see, humming softly in wavelengths that whisper rather than shine. This idea challenges the way humans naturally think. We like to imagine the universe as static, eternal, and infinite. Our senses are built for survival on Earth, not for cosmic reasoning. So, when we look at the stars and wonder why the sky is dark, we're really confronting the limits of our intuition. Feynman loved this kind of paradox because it forced us to see how our everyday logic can fail at cosmic scales. To him, the darkness wasn't a mystery to fear. It was an invitation to think differently. He once said that understanding is not about making things simple, but about making them clear. When you look at the night sky, clarity comes when you realize it's dark because the universe has a history. It had a beginning. If the universe were eternal and unchanging, the sky would indeed blaze endlessly. But it's not. It began with a bang, a moment when space, time, and light all came into existence. The darkness we see is the shadow of that beginning, stretched across billions of years. Think of it this way: when you turn off the lights in a room, it goes dark instantly. But when the universe turned on its first lights, its first stars, their glow had to travel, slowly filling space. Even now, 8 billion years later, the light is still on its journey. The darkness between stars is simply the distance between events in time. And there's another beautiful detail. Every time you look up, you're seeing the past. The nearest star's light is years old. The farthest galaxies you can see are billions of years old. The darkness between them is not emptiness, it's time. The night sky is a photograph still developing. So, what do we not know? We still don't fully understand what lies beyond our visible horizon. We can't see the first moments after the Big Bang directly. We don't know how light and matter first tangled to form stars and galaxies. And we can't yet say whether the universe will one day fade into complete darkness again, a cosmic night that lasts forever. But what we do know is that the darkness itself is one of the most important clues we've ever had. It tells us the universe had a beginning, that it's expanding and that it's evolving. It tells us that time itself has a direction, from light to darkness, from order to entropy. Feynman would have smiled at that thought. He might say, "The beauty of science is not in the answers, but in the questions that survive the answers." The question of why the sky is dark is one of those rare questions that opens up the entire universe. So the next time you look up at the night sky, don't just see the darkness. See it as the signature of creation, the evidence that you live in a universe that began, that changes, that grows. The black between the stars is not the absence of light, but the proof that light had a beginning. And perhaps that's the most profound idea of all. The darkness is not what's left when the universe forgets to shine. It's what remains when the universe reminds us that everything, even light, has a story. Write a 5-part, expanded first part 500 words without heading and brackets. Imagine standing outside on a quiet, clear night. The world feels still, the air cool, and above you stretches an endless expanse of black velvet sprinkled with stars. Each one is a sun, shining billions of miles away. And yet, despite the fact that the universe is filled with countless stars, so many that we can't even begin to count them, the sky is mostly dark. Not dimly lit, not softly glowing, but deeply black. It feels like an empty void surrounding the few bright dots we call stars. That's strange, isn't it? If there are stars in every direction, why isn't the night sky bright everywhere you look? This simple question, which anyone might ask while lying under the stars, has troubled some of the greatest minds in history. It's known as Olbers Paradox, named after the German astronomer Heinrich Olbers, who posed it in the early 19th century. But long before Olbers, thinkers like Kepler and Newton wondered about the same thing. The reasoning seems straightforward if the universe is infinite, and if stars are scattered throughout it evenly in every direction, then every line of sight from your eye should eventually end on a star's surface, just as every direction in a vast forest eventually leads to a tree trunk. Every direction in the sky should lead to a star. So the sky should be glowing constantly, as bright as the surface of the sun itself. But when we look up, it's clearly not. Most of it is black. Richard Feynman loved questions like this. They look simple but hide something profound. He would probably start by saying, "That's a good question, so good that it took us centuries to answer it." Feynman had a gift for taking big, abstract mysteries and grounding them in everyday experiences. He might ask you to imagine walking through that same forest during the day. If the trees went on forever and were packed closely enough, you wouldn't see any gaps of sunlight between them. But in the real world, forests aren't infinite. They have boundaries, spaces, and distances between trees. That's why you can still see sunlight filtering through. The night sky works in a similar way. but with rules far more subtle than those of a forest. The darkness of the sky tells us something very important about the nature of the universe. It tells us that our assumptions about infinity, eternity, and light are wrong, or at least incomplete. The first hidden assumption is that the universe has existed forever. If it had, and stars had been shining eternally, then the sky would indeed be bright everywhere. Every direction would be filled with light from some distant sun. The second hidden assumption is that light travels forever, unchanged across infinite space. But neither of these assumptions is true. The universe has a beginning, and light itself has limits. In the time before modern astronomy, people explained the darkness through myth or intuition. But the scientific approach forced us to look deeper. The blackness between the stars is not an absence, it's evidence. Evidence that space and time themselves have boundaries. Evidence that the universe is not an infinite, eternal, unchanging sea of stars. It is a living, evolving cosmos with a history written not just in the stars, but in the darkness that surrounds them. Expanded to part 500 words without heading and brackets. The first real clue to this mystery comes from something we all take for granted: light takes time to travel. It doesn't arrive instantly. It moves at a finite speed, about 300,000 kilometers every second. That sounds unimaginably fast, yet in the vast scale of the universe, it's surprisingly slow. When you look at the moon, you see it as it was about 1 second ago. When you look at the sun, you're seeing it as it was 8 minutes ago. And when you gaze at distant stars, the light entering your eyes might have begun its journey hundreds, thousands, or even millions of years earlier. So when we look into the night sky, we aren't seeing the universe as it is right now. We're looking into the past. Now, imagine for a moment that the universe had existed forever, infinitely large and filled with stars that have been shining eternally. In that case, the light from all those stars would have had enough time to reach us, no matter how far away they were. The whole sky would be ablaze with light. But that's not what we observe. The fact that it's dark tells us something extraordinary. The universe hasn't been around forever. It has an age. It has a beginning. Modern astronomy tells us that the universe is about 8 billion years old. That means we can only see the light that's had less than 8 billion years to reach us. Anything farther away is beyond what we call our observable universe. Its light simply hasn't had time to arrive yet. This boundary isn't physical like a wall. It's a limit set by time itself. The darkness beyond the stars is not empty. It's light that's still on its way, perhaps never to reach us, because the space between us and those distant regions is expanding too quickly. This realization changes the entire picture. The night sky isn't dark because there aren't enough stars. It's dark because we can only see a fraction of them. The rest of the universe lies beyond our cosmic horizon. You could think of it like standing in the middle of a huge crowd of people, each holding a candle. If the crowd is infinite and eternal, the light from all those candles should blend into a bright glow. But if the crowd is finite, and if some people are so far away that their candlelight hasn't reached you yet, you'll only see flickers of light surrounded by darkness. Feynman might smile at this point and say, the darkness is telling you something about time. What seems like a simple question about the color of the sky becomes a doorway into understanding the history of the cosmos. Every patch of black between the stars is a message from the past, a reminder that there was once a time when there were no stars at all. The early universe was a hot, dense soup of energy, and as it expanded and cooled, it eventually gave birth to atoms, galaxies, and stars. So, the darkness is more than a backdrop. It's a record of our universe's finite age and its finite speed of communication through light. It's the cosmic equivalent of a photograph still developing. Light from the most distant regions of space hasn't finished its journey. Every time we look up, we're seeing just a part of the grand picture. The rest is still hidden beyond the edge of time, reminding us that even light, the fastest thing we know, can only show us so much of the story. expanded 3 × 500 words without headings and brackets. Even if we accept that light takes time to travel and that the universe has a finite age, another question naturally appears. Shouldn't the stars we can see be enough to make the sky bright? After all, there are billions of galaxies, each containing billions of stars. Even if we can't see the ones too far away, the ones that are close enough should still light up the night. Yet they don't. The reason lies in another simple but profound truth: stars don't live forever. They are born, they shine for a time, and then they die. The universe is not static or eternal, it's a living, changing system. New stars are constantly forming in massive clouds of gas and dust, while others are burning out or exploding as supernovae. There hasn't always been light in the universe. There was a time before the first stars existed, a period known as the Cosmic Dark Ages. After the Big Bang, the universe was full of energy, but too hot and dense for light to travel freely. As it expanded and cooled, atoms began to form, but there were still no stars to shine. It took hundreds of millions of years for gravity to gather matter together into the first stars and galaxies. Only then did the darkness begin to fade. This means the universe had a time when there was no light at all, followed by a gradual brightening as stars formed and filled space with radiation. But even now, most of the universe remains dark. The regions between galaxies are vast and mostly empty. Light from one galaxy can travel millions of years before it reaches another, and most of that light is absorbed or scattered by dust, gas, or the expansion of space itself. What reaches us is only a tiny portion of all the light that has ever been emitted. Feynman might compare it to a campfire scene from far away. If you're close, the fire illuminates everything around you. But if you move far enough back, the light becomes faint, and eventually you're surrounded by darkness again. The brightness depends not only on how much light is being produced, but also on how much of it can reach you before it fades. The same is true on a cosmic scale. Stars also have limited energy. They shine by burning fuel, turning hydrogen into helium and heavier elements through nuclear fusion. This process can last millions or billions of years, but not forever. When their fuel runs out, stars fade away, leaving behind white dwarfs, neutron stars, or black holes. The light they once emitted continues to travel through space, but over time it becomes weaker and redder, stretched by the expansion of the universe. So even though there are countless stars, their light doesn't combine to fill the sky with brilliance. Some of it has already passed us, some hasn't reached us yet. Some has been absorbed by interstellar dust, and some has been stretched beyond the range our eyes can detect. The darkness between the stars, then, is not a lack of energy. It's the signature of a universe in motion, full of stars that come and go, each one a brief spark in a long and ongoing story. This changing, finite nature of stars means that the light we see is only a temporary phase in cosmic history. There was a time before stars existed, and there will be a time when most of them are gone. The dark sky we see today is a snapshot of that transition, a balance between the light still shining and the deep cosmic night that once was and will one day return. Expanded 4 × 500 words without headings and brackets. There is another piece of the puzzle, one that Feynman would have loved because it shows how subtle and strange the universe really is. Even if there are billions of shining stars, and even if light has had billions of years to travel, something else affects what we actually see. The universe itself is expanding. Space is not static, it stretches. When light moves through that stretching space, its wavelength also stretches. What begins as visible light slowly shifts to longer, redder wavelengths. Eventually, it moves beyond red light into infrared, then into microwave and radio waves, forms of light that our eyes can't detect. The light is still there, but its color has changed so much that it no longer appears bright to us. This effect, called redshift, is one of the most profound discoveries in astronomy. It means that the further away a galaxy is, the faster it's moving away from us, and the redder its light appears. Over cosmic distances, This stretching becomes so extreme that visible light turns invisible. The energy from distant stars and galaxies is still filling space, but to human eyes, the universe appears dark because that light has slipped out of our range of vision. Feynman might have explained it by comparing it to sound. When an ambulance passes by, the siren's pitch changes. It's higher as it approaches and lower as it moves away. That's the Doppler effect. The same thing happens with light. As galaxies move away from us, their light drops in pitch, shifting toward the red end of the spectrum. Eventually, it moves so far that our eyes can no longer see it. The night sky looks dark not because the light is gone, but because the universe has stretched it into invisibility. This expansion also explains why we can't see light from the earliest moments after the Big Bang. That light exists, but its wavelength has stretched so much that it now forms a faint background of microwaves spread evenly across the sky. This glow is known as the cosmic microwave background, or CMB. It's the afterglow of creation, the leftover radiation from when the universe was young and hot. Even though it's invisible to our eyes, scientists can detect it using special instruments. It's a whisper from the beginning of time, proof that the universe once blazed with light and energy. So when you look up at the night sky, you're surrounded by light that your eyes can't see. Every bit of darkness is filled with invisible waves, infrared from distant galaxies, microwave radiation from the early universe, and radio waves that stretch across space like a faint cosmic hum. The sky is not truly black. It only seems black because our vision is limited. This realization shifts the question entirely. The darkness of the night is not a sign of emptiness. It's evidence of the universe's expansion. The light is there, transformed, spread thin, stretched across time and space. Feynman would have pointed out that nature doesn't hide her secrets. She just expresses them in forms we're not always built to perceive. What seems like absence is really presence in disguise. The dark sky is not darkness at all, but the faint, stretched out echo of an ancient brilliance that still fills the cosmos. Expanded fast part 500 words without heading and brackets. When we understand that the universe is expanding, that light stretches and fades, and that the stars themselves live and die, a deeper realization begins to form. The darkness of the night sky isn't just a background, it's a message. It tells us about the birth, evolution, and fate of everything that exists. What we see when we look up is not simply a picture of stars scattered in space, but a history written in light and shadow. Every star is a piece of the story, and every dark patch between them is part of the same cosmic sentence. Feynman would have said that this kind of realization is what makes science beautiful. A simple observation, something a child could wonder about, turns into a key that unlocks the deepest truths of the universe. The night sky is dark not because the cosmos is empty, but because it had a beginning. There was a time when light did not exist, and there will come a time when it fades away. The darkness we see now is the boundary between those two realities, the echo of a fiery birth and the hint of an inevitable silence. This leads us to think about time in a completely new way. Every photon of light that reaches your eyes tonight has traveled for years, centuries, or millennia. The star you're looking at might already be dead, its light continuing its journey long after its source has vanished. The sky is a vast archive of moments long gone, a cosmic memory written in light. The darkness between the stars isn't empty space, it's time itself, the distance between now and then. When we look up, we're not seeing what is, we're seeing what was. Humans struggle with this because our senses were not built to grasp cosmic time. To us, darkness means nothingness, absence, or emptiness. But in truth, the blackness of space is overflowing with meaning. It is filled with radiation we can't see, with galaxies too far to detect, with light still on its way. It's the universe's way of telling us that our view is incomplete, that we are part of something still unfolding. Feynman would remind us that understanding doesn't remove the mystery, it deepens it. The more we know, the more wondrous the universe becomes. And there is something profoundly philosophical hidden in this scientific truth. The darkness is not a flaw in creation, it's a feature of it. It reminds us that everything, even light, has limits. That beauty is often found not in what is visible, but in what is hidden. The night sky is dark because the universe is young compared to eternity, because it's still growing, still cooling, still telling its story. So the next time you look up and see that vast black canvas scattered with points of light, don't think of it as emptiness. Think of it as a snapshot of cosmic history frozen in motion. You are witnessing the aftermath of creation itself. The darkness is not the absence of light, it's the proof that light had a beginning. It's the reminder that time moves forward, that everything changes, and that even in the quiet of the night, the universe is still alive, still expanding, still whispering its story to anyone willing to look up and wonder.